epidemiology. We're looking at pathways of diseases that affect both humans and animals and the interactions among them that are caused by sort of broader political economic changes on the island. So this work is still in the very early stages, and this particular talk I'm drawing on other studies that have been already conducted in the region about the health, in this case, of lemurs. And, but it draws also on my long-time field work in the region and some recent trips to Madagascar where I'm starting to explore the field site. So I think it's going to be a little long. I might have to cut portions of this talk. I hope it's comprehensible. Okay, so the talk today is called Spiraling Down: Biodiversity Offsets, Pathogenesis, and Primate Futures in Madagascar. And most of you know probably where Madagascar lies. It's in the Indian Ocean off the east coast of continental Africa, and it's a large island. This is the large island, and the inset is a mining region where I'm focusing my field work now. So incursions into the thick of the rainforest have always threatened people's health in Madagascar. In the 19th century, Europeans dreaded traveling the treacherous road that led from the port of Tuamasina, that's where one of those red stars are, toward the central highlands and to Antananarivo, where people paid respects to the Marana monarchs. Hearsay has it that King Radama I intentionally kept the road to the east rugged as a defense against military invasion by Europeans. He bragged of having 2 officers in his command, General Hazu, Hazu means forest, and General Tazu, Tazu means fever, able to overcome any challenger. But how could he have known that over time, feverish General Tazu would grow fiercer as General Hazu wasted away? Their respective vitalities have been linked but unbalanced. The island's thick rainforest belt along the east coast that once posed a formidable barrier to European conquest from the east has been whittled down to a fringe. The process of deforestation has both generated wealth and enabled the reproduction of Malagasy society over time. However, it's also erected walls for wildlife species, obstructing the migration of groups that ensures their reproduction. Deforestation has increased opportunity for disease-carrying rodents to proliferate, many of which transmit lethal diseases to other mammals. Land clearance has moreover provided fertile grounds for disease vectors, hosts, and not quite species life forms. Mosquitoes thrive in spaces cleared of woods and have adapted to human hosts and blood, transmitting febrile diseases such as malaria, chikungunya, and dengue, also lethal fevers. Political ecologists, social scientists interested in the power dynamics between people and groups that cause sort of environmental change, they've been attuned to the ways in which these unequal power relations shape the allocation of and access to natural resources differently, as well as exacerbate land degradation. Yet they've paid relatively little attention to the ways in which these hierarchically organized activities in primary habitats have reconfigured wildlife species and have affected interspecies health. For example, in Madagascar's eastern rainforest belt, deforestation has led to the proliferation of black rats, a reservoir species of bubonic plague, and plague still causes episodic breakouts. In Madagascar, there was a bad breakout last November 2014, and it's still not entirely finished. Bats, which carry a variety of pathogenic bacteria and viruses, tend to migrate into human settlements to roost in human-made dwellings when the forest canopy disappears. The rising incidence of disease spillover from animal to human, called zoonosis, around the world reveals the porosity of species boundaries we have believed to protect us from non-human diseases. In this talk, I focus on the ways a relatively new geographical and ideological construct called the biodiversity offset not only reflects a historically specific political relationship between transnational capital, the Malagasy state, and subsistence-based populations in Madagascar, but the biodiversity offset also does generative work. I mean, it produces something. However, the generative or productive work delivers undesired and unintended outcomes, as I'll show today. So by this, again, I mean the biodiversity offset, which is an ideologically burdened, protected forest fragment standing amidst a denuded landscape. It intends to preserve current populations of wildlife species into a future time in which extractive activities will have abated. What's more, it intends to preserve into the future the current assemblage of wildlife species we see today in a variety of biodiversity hotspots like Madagascar. However, evidence suggests that the biodiversity offset is reconfiguring future biodiversity in a negative way, or at least negative to humans and their species familiars, primates, in this case lemurs. So I examined the assemblage of species caught up in the space-time of Madagascar's ascendant economy of repair of damaged nature. That's a phrase used by other scholars, the economy of repair of damaged nature. As scholars have established, the repair economy financializes nature. It depends on manipulable metrics, compliance enforcement mechanisms, and self-monitoring and self-assessments by firms that endorse the environmental goals of international agreements such as the Kyoto Protocol. In many countries, the repair economy takes the form of mining companies managing biodiversity conservation efforts and adding value to the company by trading in the fictitious capital of ecosystem services. Global donor institutions aim to cultivate good corporate actors who share a desire to produce a resilient and vital ecosystem where they're operating, while pursuing conventional erosive means of resource capitalization. Madagascar hosts two giant mining operations, Ambatuvi, and that's what this map is showing, the region of Ambatuvi, that's my current field site, and another one, another company called Rio Tinto, which is a UK and Australian corporation, a mining corporation. Both of these companies in Madagascar have implemented biodiversity offsets near their mine sites to neutralize the damaging effects of ore extraction, namely the damaging effects being biodiversity loss and land degradation. The biodiversity offset, a protected nature reserve, is one instrument within the growing market of correctives to climate change, habitat loss, species extinction, and grinding poverty insofar as poverty exacerbates ecological degradation. Offsets serve to bank wildlife species for future restoration works once a mine shuts down, and ideally to produce what they call a net gain of biodiversity over time. By providing a well-financed refuge to endangered species, biodiversity offsets promise to resuscitate the lifelines of living dead species, or those slated to die out due to habitat depletion. So I'm interested in the ironic outcomes of these green mining initiatives, the unintended biodiversity of, and adaptive responses to this dynamic of degrading while conserving habitat. What if, as the future unfolds, scientists discover that biodiversity offsets have yielded a net gain of microbial life, a profusion of unloved others, viruses, helminths, bacteria, much of it pathogenic to mammals? Emergent within the landscapes of the repair economy are these invisible yet powerful forms of life and death that negate the optimistic industry rhetoric of post-mining ecological vitality. Studies in Madagascar suggest that rather than moving toward ecological rebound, remnant biodiversity is spiraling down. I mean this in three senses: in the scope of biodiversity, the scale of visibility of life forms, and the vitality of primates and other species of concern to conservationists working with and within the extractive industries. Regarding the scope of biodiversity and protected forest fragments, the erosion of primary forests through mining and other extractive activities can set into motion a process of despeciation, as subspecies, once inhabiting distinct zones or ecological niches, begin to hybridize in their reduced ranges. While the hybridization of subspecies does not involve species extinction per se, it does complicate the calculations of biodiversity offset managers who seek to show a future net gain of biodiversity within offsets. So you understand, like when subspecies start to breed and sort of combine, that really diminishes the diversity of biological species. So if you're just looking at calculations of biodiversity net gain, this is a complicating factor. Regarding the scale of life forms, I'm suggesting that forest fragmentation, mining, and offsetting are cultivating the growth of microbial life forms, viruses and bacteria that pose a risk to humans and non-human primates as well as other mammals. Human activities trigger emerging infectious diseases by pushing novel pathogens into new ecological niches, or altering the environment in such a way that fosters the growth of pathogens, a process called pathogen pollution. Due to the increasing number and virulence of pathogens in degraded environments, the health of multi-species communities in Madagascar appears to be in decline or spiraling down. Since we tend to be especially sensitive to the plights of our fellow primates, people around the world are aware of the endangerment of lemurs, Madagascar's flagship species and the most imperiled group of vertebrates on Earth. Madagascar's lemurs are the primary species of concern here. I therefore examine the effects of resource extraction, forest fragmentation, and conservation on lemur populations in order to expose the problems of biodiversity offsetting. Since they are closely monitored, lemurs serve as canaries in the coal mine with respect to the health of mammals and perhaps other vertebrate species. Not only have the ecological roles and faunal charisma of lemurs earned them a special status in Madagascar's mining sector, but scientific findings also suggest they are sentinel species. That means they indicate trajectories of other mammalian lives in the island's current political economy. The word sentinel is somewhat misleading because it sounds like the lemurs are watching out for us, but we're really watching out for them. So in what follows, I describe Madagascar's thriving mining sector, the context in which the biodiversity offset took shape. I then describe the biodiversity offset as a social construct, attending to how the architects of biodiversity offsets imagine space and time in future life. And then I turn to the practical steps taken to achieve this future. Finally, I examine studies that allow me to speculate on the biological and behavioral effects of biodiversity offsets on primates. I draw inspiration from the concept of One Health, which is a global initiative that stresses the interdependent well-being of people and critters that compete, play, prey on, and eat, and infect one another within ecosystems, swept up in this case by mining and ecological mitigation ventures. The term comes from the One World, One Health initiative. This is a global movement spearheaded by medical and environmental scientists seeking to resolve the emergence and spread of zoonotic disease, or disease that jumps from animals to humans. Primate bodies and interspecies interactions indicate signs of increasing pathologies for lemurs and human populations over generations and within the unpredictable ecology of Madagascar's repair economy. These days in Madagascar, talk of minerals, the wealth in the belly of the earth, or Harana Kibuntani in Malagasy, pervades the tourist hotels of the capital and the gritty boom towns of Sapphire Country. Along the eastern humid forests and sandy coast, in the northern limestone-bladed landscape of the southern dry spiny forests, prospectors in search of gemstones, gold, and industrial and rare earth minerals are digging deeper into the island's crust. Although mining companies tout the jobs and economic development they bring to regions, their ventures stir social unrest and wreak havoc on the island's already fragile ecological health. The slackening of mining regulations in the early 2000s was quickly followed by political turmoil, making Madagascar less regulated and therefore all the more attractive to foreign mining companies. So there was a coup in 2009, which led to another period of instability. But during this longer term of instability between 2001 and 2009, a lot of foreign mining companies came into Madagascar, and there was a huge investment in this sector. And you see now rampant sort of mining taking place everywhere, included areas that were once protected as nature reserves. And as I said before, two of the biggest mining companies are Abatuvi, which mines cobalt and nickel. So here's some of this nickel bars, and Rio Tinto, which dredges sand to mine ilmenite used in paints, etc. Let's skip ahead here. Okay. Madagascar, as many of you may know, is considered by scientists to be a biodiversity hotspot because of the rareness of its species that exists nowhere else on Earth. Over 90% of Madagascar's plants and animal species are endemic. They exist only there. And it's a hotspot due to the high level of endangerment of these species due to human activity. Habitat fragmentation and degradation trigger a downward spiral of ecological health and communal well-being. Mining industry insiders are aware of the health risks of extracting ore from tropical forest. As David Heyman, head of the Center on Global Health Security in London, said recently at a mining conference, infections jump from animals to humans regularly, and there's always a need to consider emerging infectious diseases in business. Extractive activities may stir up viruses from the deep forest interior and amplify their populations as animals and people mingle with previously hidden microorganisms. In addition, anthropogenic climate change reconfigures habitat overlaps, shifting microbes to mammal ranges and exposing plants and animals to new pathogens. As concerns the social effects of mining on local populations in Madagascar, the mining giants, Ambatuvi and Rio Tinto, would argue that they offset negative outcomes of their interventions by implementing community development projects and remedial environmental projects when necessary. Yet, changes in the mood of a place and interpretations of that change by residents in cities and villages affected by mining are not easily manipulated by industry interventions. On much of the island, smaller mines also are being dug, and they're largely unregulated. Along the eastern escarpment or forest range and the sandy beaches, many smaller operations dredge sands and dig open pits. It's rumored there that miners suffer from skin lesions and respiratory ailments from whatever they're extracting. Many of these smaller mines are owned by East Asian companies, and they do not aspire to improve environmental sustainability or public relations. For the mining giants, public and global scrutiny make them more conscientious. Ambatuvi in Malagasy means at iron rock. It sits on a nickel and cobalt-rich pluton, a body of intrusive igneous rock lying approximately 120 kilometers from the capital, Antananarivo. It was built in 2007, and it's jointly owned by Canadian and East Asian companies. The mine site is inland in the forested eastern region. Its tailings management facility and mineral so this is the mine site, but its tailings facility are up here off the coast. So that's the interior mine site. At the coast, at the port city of Tuamasina, where the tailings facility is, Malagasy people complain about fumes of the facility causing fetal mutations, stillbirth, and cancers, and this is sort of the rumors that are circulating in the city there. And these rumors exasperate employees of the Ambatuvi mine, even though they have become used to them. When verifiable injuries do occur, such as the release of sulfur dioxide gas during a power outage in 2012, and this caused eye irritation and throat irritation and browned vegetation, the Ambatuvi's corporate social responsibility team has worked quickly to provide medical care to affected individuals and to compensate them for damaged property. Another social problem to offset through community enrichment projects concerns labor tensions. The tendency of the big companies to hire skilled outsiders rather than train local residents has fostered discontent. There's been protests at both mine sites and large strikes and sometimes violence. So the mines try to sort of tamp down this resistance and also mitigate their image and sort of to the global public. At Ambatuvi, Malagasy residents resent the fact that the jobs have gone mostly to foreigners or Malagasy outsiders or people not from that particular region. Residents of Tuamasina on the coast point out that the changed demographics of the city caused by Ambatuvi's employment practices, and they link this to rising crime rates, a sense of disenfranchisement, and growing poverty that have tarnished the city over time in the eyes of residents and tourists. In the more rural areas of Madagascar, people recognize the hypocrisy of the mining companies acting as conservation authorities through the establishment of biodiversity offsets, a theme which I'll turn to later on. Let's go ahead. Predictably, the Ambatuvi staff has also weathered complaints from foreign environmentalists who disparage the excavation of the open pit and slurry pipeline in a fragile, biodiverse rainforest. You can see here the mine site. This is all primary rainforest here. This is the mine site and the roads that they use to transport materials. It's just slashing through the not only the forest here, but also a wetland area that's been protected. In 2004 and 2007, scientists managing the wetland discovered a population of the critically endangered greater bamboo lemurs, deemed one of the most endangered primates of the world. So the destruction of 1,400 hectares of primary forest by Mbatuvi agitated conservationists who worried about the fate of this species and others. To critics, Mbatuvi representatives countered that their mitigation and restoration works have already proven that the mine is not the ecological catastrophe many assumed it would be. So I visited there in July 2013. I was escorted by a British man who was the head of the environment team of the mine. And so they were in charge of managing the biodiversity offsets of this mine site. He showed me the native tree saplings planted only a couple of years earlier and quickly along the banks of the dirt road lying along the slurry pipeline. He pointed out where workers sprayed grass seeds to prevent soil erosion. He showed me a dam that they built to trap sediment and avoid spillage into the river, which had become a refuge for an endemic species of duck. And he showed me an assortment of native orchids that were awaiting transplant from a reserve into the degraded forest. So he's showing me all this wonderful environmental activities they're doing to preserve biodiversity and to even transfer threatened species that are in these forest fragments into the biodiversity offset. In fact, within the global mining industry, this mine, Mbatuvi, has earned accolades. It was the winner of a special award, the Nedbank Capital Sustainable Business Award, thanks to its landmark biodiversity management program in Africa and the creation of value for community and the environment. So these banks sort of reward big corporate actors like the Mbatuvi mine for their green initiatives. The biodiversity offset program is the cornerstone of environmentally sustainable practice for the mining industry. Now, this is called the Business and Biodiversity Offset Program, the BBOP, which was launched in 2004, was conceived as a joint venture of business, governments, the World Bank, and conservation organizations. It fits into the broader initiative, reducing emissions from deforestation and forest degradation, called REDD, R-E-D-D. REDD sets up a mechanism that allows wealthy countries that have cleared most of their primary forests to offset their excessive CO2 emissions by paying poorer but forested countries to reduce their deforestation rates. This strategy implies, as Barry Ferguson notes, that it's easier to stop a poor peasant from clearing rainforest than to stop a corporate polluter in the industrialized north. Specifically, the BPOP establishes a protocol by which mining companies commit to preserving areas of habitat biologically and geologically similar to those sacrificed to mines. The move entails spatial dislocation. The damage I'm doing here is offset by the good I'm doing over there, and a time lag. The damages that are happening right now will be repaired later. The logic of biodiversity offsetting, in effect, parenthesizes the effects of mining, as though to say mining's ecological harms are a future historical aside. Biodiversity offsets reflect capital-intense conversation with itself as big industry strategizes to resolve opposing directives, extract and tolerate unavoidable ecological and social damages on the one hand, conserve and restore ecosystems on the other. The literature of mining companies tends to depict mineral extraction and wildlife conservation as distinct spheres of rainforest conservation and extinction in Madagascar for a long time. I'm interested in the ways biodiversity offsets are like, yet unlike, other protected areas, both in their promise of future ecological and species health and in the obfuscating work they achieve in the present. In and of themselves, biodiversity offsets are comparable to many other protected sites in Madagascar, national parks, special reserves, and integral nature reserves. They are surveilled and maintained by a project staff who must communicate with villagers who reside at the boundaries, informing them of prohibitions against resource extraction and urging them to adopt more sustainable livelihoods than slash-and-burn agriculture and artisanal mining. Biodiversity offsets are thus subject to the same maintenance and anthropogenic pressures of any other forest fragment. Ideologically, however, they differ in their representation as lifeboats into the future and absolvers of mining wrongs. Also, unlike NGO and state-managed protected areas, mine-managed conservation has access to greater reservoirs of capital, including mineral profits. It likens offset biodiversity to what Marx would call fictitious capital, comparable to tradable paper claims to future wealth. The future net gain of biodiversity implies a benign increase in the population numbers of existing floral and faunal species, particularly the endangered ones. This logic implies that degrading while conserving habitat will eventually improve ecological health and ideally increase biodiversity. At the very least, offset planners can sell the counterfactual that ecological conditions will be better off than they would otherwise be had the offset never been established. Now, to lay the groundwork for evidence to prove that they're sort of achieving a net gain of biodiversity, the use of metrics is essential. Metrics enable a comparison of the exchangeability of habitats and selection of offset spaces, as well as the loss or gain of biodiversity over time. The ambiguity of the term biodiversity poses some problems for measurement, however. As Ursula Heise explains, biodiversity pertains at the level of the ecosystem, of the species, and of subspecies variation, so that bare numbers of different species in a particular ecosystem can only give an incomplete picture of its biodiversity. On the ground, moreover, offset planners acknowledge the trickiness of trading like for like, or in-kind habitats, particularly in the ecological mosaic of a rainforest, where assemblages of species are highly variable as one moves over the surface, as we find in Madagascar. You go just a short distance and the sort of configuration of species looks very different. This high degree of microendemism, as it's called, results from variable geology, geomorphology, substrate, topography, and mesoclimate. Numerical indicators of biodiversity loss or gain are therefore unreliable and fraught with subjective choices, and vested interests in what gets counted and when. The uncertainty of knowing the future in light of these moving targets, such as migratory species and ecological changes, complicates calculations. Offset planners control this uncertainty to some degree through the use of spatial and temporal multipliers. These are factors by which the amount of offsetting required per unit of projected biodiversity loss is increased to account for uncertainty in both the biodiversity losses and the success of that offset itself. Multipliers can allay theoretical uncertainty in how to define and measure biodiversity, and they enable a fair exchange of future gains against current losses. Quantitative data are essential to proving in the future that these hypothetical species banks are staying solvent and possibly accruing life, discounting for factors beyond the control of the mining offsetting project, such as climate change, which all told has actually been exacerbated by extractive activity. So these mining companies are creating calculations that discount rates. Well, you can't really help that climate change is happening, so we'll give you a break in the future. You don't need, they do these quite complicated calculations. But of course, as I'm saying, mining actually exacerbates climate change, so are they implicated in this or not? That's a question. To what extent can the unpredictable vicissitudes of history and nature figure into discount rates and net gains of biodiversity offsets? A look at the daily tasks of protecting species in an offset sheds light on the formidable challenges to protecting extant species populations, let alone to accruing biodiversity in the long term. So in this section, I want to describe some of the concrete tasks people are doing to translating the ideology of the biodiversity offset to the ground, to show how, what are the tasks, what is the labor involved in protecting species into the future. At Ambatubi, the environment team established 2 biodiversity offsets to absorb the wildlife displaced by the mine. Again, these are pictures of the Ambatubi mine site. You can see it's quite a dramatic change in the landscape when it was all this before. This is just some slides. The slurry pipeline taking the water and sludge from the mine, to clean out the ore, taking this all the way to the coast, to the tailings facility. That's the harbor extension where ships take the ore out to international markets. This is back at the mine site, and this is the biodiversity offset, one of them adjacent to the mine site. So at Ambatubi, the environment team established 2 offsets to absorb the wildlife. This one's near the mine, and the other one is quite a bit farther because they thought it was geologically and biologically similar, but it turned out to be quite different. As the earthworks were launched for the mine site, a few villages in the area had to be relocated to accommodate some mining infrastructure. Resettlement sites were built both near the mine site and the coastal processing plant. Ambativi staffers conducted an environmental impact assessment of the would-be mine's footprint and collected floral and faunal inventories. Employees and consultants identified key biodiversity components that would be disturbed by development activities, including 16 lemur species, 62 bird species, 123 reptile species, 5 fish species, 24 insect species, 376 plant species, and an additional 33 plants that were species of concern identified as rare in Madagascar. So they have to be in charge of making sure all of these species survive into the future after the mine shuts down. The known lemurs of these are the main species are shared, and animals such as lemurs venture out into human settlements. When the Ambativi staffers built the slurry pipeline and the road that runs parallel to it, they slashed through an expanse of biodiverse rainforests and interrupted the movement of animal populations, thereby jeopardizing their reproduction into the future. So if lemur populations can't migrate to different areas, that jeopardizes their reproductive capacity. Fragmentation can mean several things, including habitat loss, increase in the number of habitat patches, decreasing size of habitat patches, and increasing isolation of habitat patches. Researchers have found that larger habitat patches possess greater allelic richness. That's a measure of genetic diversity, indicative of a population's long-term potential for adaptability and persistence. In certain lemur populations, if they're in a smaller habitat patch, that lessens their allelic richness over time. Small fragmented populations of species are more vulnerable to extinction due to lessened genetic variability, and this also makes them more susceptible to infectious disease. The environment team of Ambativi worried that the road would isolate lemur groups on either side of it, thereby impacting genetic diversity, health, and population survival. So what did they do? They erected 7 lemur bridges. That's one lemur bridge that spans the road that they had to create. They were hoping that lemurs would learn to transverse the bridges and thereby be able to sort of migrate into new habitat areas. They were hoping that this is the way they describe lemurs, that the clingers and the leapers and species that move quadrupedally would rather avoid descending to the ground to cross the road, because they do prefer locomotion through the trees. Now, whether these bridges would substitute for the treetops was a gamble, and to determine whether or not the bridges would be used by lemurs, they had observers stand at the bridges for 4 to 6 days a week for a total of 764 observation days in 2009 and 2010, or nearly 8,000 hours of watching time. They eventually did see 6, after all this time, they saw 6 highly arboreal diurnal lemur species gradually and tentatively begin to climb across the bridges, as well as cross the road on the ground. But since no one observed it at night, they don't know what the nocturnal species were doing. So this is just an example of the painstaking attempts that people must do in the offset to make them viable. So they constructed these bridges, and they also, literally, when they see a chameleon or a lemur sort of walk out into the mine site, they have to pick them up by hand and walk them back into the forest. This is really the scrupulous care that's necessary to, ensure that their numbers pan out in the long term. I'm going to skip ahead now to talk a little bit about, for the sake of time, to talk about the effects of forest fragmentation such as this on primate health as sort of indicative of what's happening not only to lemurs but also humans around these forest fragments and also other mammalian species. In Madagascar this season, when people burn forests to prepare land for cultivation before the rains begin, this is the period when they frequently come into contact with wild lemurs who often linger at the cut forest edge. The increase in human population density near forest fragments, caused in part by the pull of mining jobs, appears to increase the incidence of infectious disease. Higher density puts a strain on food resources and forces people to eat more bushmeat, or wild protein, a potential source of disease also. Domestic animals also succumb to zoonotic diseases such as anthrax, brucellosis, or rabies, and can transmit them to wildlife populations. The circulation then of pathogens amongst humans and wild and domestic species is part and parcel of the vitality of these mosaics of strip-mined land, settled land, and rainforest fragments. So returning now to the lemurs, we can see how the microbiological and ecological effects of mining have in turn made lemurs more vulnerable to extinction. Recent published studies of lemur populations in the region and similar forest fragments illuminate the residual impacts of earlier forest degradation and the intensification of physiological stress with the progressive encroachment on primary habitat by people and their livestock. So one study that was carried out near Ambatuvi was a study of the injury lemur, which is the largest lemur that exists in Madagascar. It's a black and white species. This study sought to assess the potential health effects of habitat fragmentation, mining, and anthropogenic pressures on injury health. Research compared two population groups, one in an undisturbed forest reserve, the other in a disturbed forest reserve, heavily trafficked by tourists, and near several graphite mines as well as the Ambatuvi mine. The two groups showed marked differences in blood cell counts. Injury of the undisturbed forest demonstrated higher values for molybdenum and selenium. Notably, the researchers also found that serum trace minerals also differed. Injury of the disturbed forest exhibited higher values for nickel, cobalt, manganese, and zinc, with differences being at least twofold greater for all values except zinc. Now, it's not yet known whether the absorption of minerals will affect the reproductive cycles of lemurs, but this is a concern. And I've been collaborating with a veterinarian based at Duke University, and she's actually hired by the mine to monitor lemur health. And her data are secret. She can't share with me the results of her own studies on lemur health because the mining company guards that, so it's very confidential information. But this earlier study done in the region after the mine began, where minerals are being absorbed by lemur bodies, indicates there's a process going on, what the effects are. The veterinarian may well know, but she can't tell me. As the Ambatuvi mining operation spirals deeper into the earth, the minerals extracted from the bedrock flow into the water systems and find their way into animal bodies. Injury of the disturbed forest also had a higher ectoparasite diversity and co-infections. That means more than one parasite. The fate of lemurs will testify to the sustainability of biodiversity offsets, yet the scientific findings regarding lemur health have so far remained confidential, as I said, kept within the confines of the company. Beyond Ambatuvi, at similar sites, the studies of lemur health are quite rare. They're quite scarce at this point. But in other studies of lemur health around forest fragments, where there's a lot of degradation around the protected area, other research shows that viral, bacterial, and parasitic pathogens are moving among lemur populations and humans, reflecting how disease pathways link together to make health a collective condition. One study showed that lemurs in an undisturbed portion of another national park carried none of the bacteria, that the most common being E. coli, that did sampled lemurs from a more tourist-trafficked area. Researchers also found a similar pattern for gastrointestinal helminths, like worms, and protozoa infections. Lemurs in the undisturbed area of the park fared better than those in the disturbed area. These findings suggest mixed fortunes for lemurs. The species whose food sources are vanishing with the decimation of habitat may succumb to extinction more rapidly than those able to behaviorally adapt to life around the edges of human settlements. But diseases of the mouth and skin and an increase in body size due to access to human food sources, and that was just the picture of that little tiny lemur, and intergroup fighting suggests a trajectory of declining health for these lemurs near human settlements. Humans-lemur interactions are not limited to the physical contact through play, hunting, and consumption. They're also mediated by the consumable goods and waste products of human beings that circulate in contact zones and through soils and rivers. Okay, so you get a sense. I have other studies I'm not going to cite right now, again, for the sake of time, but I want to conclude here that the emergence of biodiversity hotspots marks a historical fork in the road for green capitalist discourse. From a period from the late 1980s to early 2000s, when some protected areas, called parks, were championed as revenue-generating ecotourist attractions, and others, namely special reserves, were considered sites for bioprospecting and research. Toward what we have now, the current moment in which mining companies act as conservation managers. Biodiversity offsets offer hope of ecological restoration and future biological gain. Offsetting discourse casts mining companies in a more environmentally responsible light and organizes the present-day tasks of Malagasy mine employees, contributing to their sense of purpose and job satisfaction. But it also insinuates a particular plan for the future into multi-species communities. I've used this metaphor of bank or species bank to describe the strategy of biodiversity offsetting, the idea that biological diversity will accrue interest over time by increasing the size of species populations, if not actual diversity rates. But perhaps the bridge metaphor is more apt here. The biodiversity offset offers a narrow bridge to the future, a survival plank for a variety of key species, while all sorts of habitat devastation goes on below. As a bank or a bridge, however, the biodiversity offset suggests that ecological wrongs are correctable, that ecological restoration can even improve on the original conditions of mining. The rationale of offsetting, however, does not reconcile with the holistic understanding of habitat health and species well-being, tangled up with human livelihoods and health. The tangle of life forms constitutes a totality of well-being at large scale. Unless it devolves to the point of no return, biodiversity as we know it will always require the support of networks of defensive wilderness barriers that keep microbial invaders at bay. The end.